Now that we're familiar with the approach being used to solve simple equations, we're going to apply it to three examples. So in this first example, we have 5/3 x plus 7 equals 22. Remember, first thing you do is check to see is the left side, is the right side simplified. 5/3 x plus 7, can't combine any terms. You're going to leave it alone. 22, all by itself, it's simplified, you leave it alone. Now we work on trying to isolate the variable, isolate x. To do this, we're going to have to get rid of any addition or subtraction going on first. So I'm going to subtract 7 from the left side and subtract 7 from the right side. That's going to give me 5/3 x equals 15. Now, before you go ahead and say, well, divide by 5/3, don't do that. When you have a fraction coefficient, understand the concept between what's going on. When you have 5/3 x, you're really taking 5 times x and then dividing by 3 for it. So when you have a fraction coefficient, don't go to your calculator and divide by the fraction. You may input it wrong, which will give you the wrong answer. So what you do if you have a fraction coefficient is you multiply the left side and the right side by the reciprocal, which means flip the fraction. So you multiply both sides by 3/5. The reason why is because the 3 on top and the 3 on bottom are going to cancel out. The 5 on top, the 5 on bottom are going to cancel out. And so I'm left with x equals, x is all by itself, has a coefficient of 1. Left side's good. Now we take 15 times 3/5. Again, don't go to your calculator. Don't be that student that always goes to their calculator. It's not hard to take 15 times 3/5. If you have an integer times a fraction, just take 15 times the numerator, so 15 times 3, and then divide by 5. So 15 times 3 is 45. 45 divided by 5 is 9. And so I have x equals 9 for my final answer. The other way of doing it is I could take 15 and divide by 5, which gives me 3, and 3 times 3 is 9. It was simple to do without a calculator. Just push yourself a little bit to understand it. And it's also expected of you on non-calculator tests to be able to do this. So understand the concept behind it. Now we look at example 2. And I see right away in example 2, I have 1/2 times the quantity 4x minus 6. I have 3 times the quantity 2x minus 9. So right away I see I have to simplify the left side by distributing, and I have to simplify the right side by distributing. So I take 1/2 times 4x, which gives me 2x. I take half of 6, so it's going to be 2x minus 3. Equals, and then I distribute the 3 to both terms, and I get 6x minus 27. If I look, I see I have a variable on the left side. I have 2x. I have 6x on the right side, so I'm going to have to combine the variables on one side of the equation. So I'm going to move the 2x over to the right side. So subtract 2x since it's a positive 2x. And that allows me to say that I have negative 3 equals 4x minus 27. So in this case, I'm going to add 27 to both sides to isolate the variable. And that's going to give me 24 equals 4x. So if I divide both sides by 4, x equals 6. And that is my answer. So in this example, I noticed that I had to simplify the left side, I had to simplify the right side before I even went to isolating the variable. In this case, I did not have to do any simplifying on the left side or right side, but this was an important one to go over because it taught us how to get rid of a fraction coefficient. And now if we look at the last example in this exercise set, this one has fractions, and so I have 4/3 x minus 8 equals 8/9 x minus 6, and right away people look at it and go, oh no, fractions, what am I going to do? And what you do is realize fractions are just a fancy way of writing division. So 4/3 just means I'm taking 4 dividing by 3. 8/9 just means I'm taking 8 and dividing by 9. And if you don't like fractions, if you don't like working with them, then do the whole part of algebra. The main theme is manipulate an equation or expression into a form that you can work with. So if you don't like fractions, then let's get rid of the fractions. Now to do this, what you're going to do is multiply the entire equation by the least common multiple of the denominators. So I want to know what's the least common multiple of 3 and 9. So the multiples of 3, 3, 6, 9, 12, 15, 18, 21. Multiples of 9, 9, 18, 27, 36. You know, what's the multiple they first meet at? And that would be 9. So I'm going to multiply the entire equation. So I'm going to multiply the left side, and I'm going to multiply the right side by that LCM. By doing it to both sides, it's going to keep the equation balanced. And so I'm going to distribute 9 through on the left side. And take a look, an integer times a fraction. Use the approach that we looked at in the first example. Take 9 times 4. That's 36. 36 divided by 3 is 12. So I have 12x, and then 9 times 8 is 72. If I take the 9 and distribute it on the right side as well, well, if you take a look and you distribute to 8/9, I mean, the 9 and the 9 are going to cancel each other out. So I'm left with 8x, and then 9 times -6 is -54. Take a look at what happened. When we multiplied by the LCM of the denominators, the least common multiple of the denominators, we now have an equation with no fractions at all. So we're not comfortable with working with fractions. Maybe you don't like fractions, so get rid of them and work with the form that you are confident with doing. So in this case, I know subtract 8x from both sides. And that's going to give me 4x minus 72 equals -54. And then I'm going to keep on trying to get this 4 by itself, the 4x. So I'm going to add 72 to both sides. And that's going to give me 4x equals 18. And so now I divide both sides by 4. And again, oh no, 18 divided by 4, it's not nice. If I went to a calculator, it's a decimal. Simplify the fraction. 18/4, they're both even. So if I take a 2 out of the top, it's going to give me a 9. Take a 2 out of the bottom, gives me 2. X equals 9/2. So when you have a fraction, what you're expected to do is simplify the fraction. Do not give me a decimal for it. Do not round a decimal. Give me the simplified fraction for it, and that is your answer. So these were 3 examples, and they covered some pretty good concepts that you're expected to know in Algebra 2. Be comfortable with this concept before you move on to the next exercise.